Greetings everyone. Today we're going to explore dividing radicals. For this video, you'll want to have our foldable that we have from class, but you can quickly jot it down in your notebook if needed. Let's jump to the top half of our foldable and let's just jot down some notes, some key ideas on how to simplify radicals with division. First and foremost, a general math rule. We can only divide radicals if they have the same index. Now, if we're in Algebra 1, we're probably going to stick to just square roots, so this won't affect you. But if we are going into geometry in Algebra 2, you could have cubed roots, fourth roots. Then you have to make sure they have the same index. These next 4 bullets are the steps and processes we're going to use to simplify using division. Now, there is no order for these steps, so your work could look different than somebody else's and still arrive to the same simplified expression. One option is if you have 2 small radicals, you can replace it with 1 large radical. For example, if I have square root of 10 over square root of 5, I'm going to actually make that square root of 10 over 5, right? Because then I can divide and simplify that down pretty quickly. So in that case, it would be beneficial to take 2 small radicals and make it 1 large one. In that instance, we can then simplify the fraction under the radical. If you're given something like 3/12, right, you want to reduce that. You want to simplify that down to 1/4. The next bullet, you want to rewrite with small radicals again. For example, if I take a look at this one, I want to rewrite it with small radicals because what's the square root of 1? 1. What's the square root of 4? 2. So even though this fraction I couldn't do much with at the time, if I reduce it, rewrite it as separate, I can get it down to a nice clean fraction. Now you're going to have a lot of square roots of 1. That's just 1. Square root of 4 is just 2. Don't try to double square root. That tends to be a pattern I'm noticing. So make sure you get it down to something that you can square root. That's a perfect square. And then simplify the radicals if possible. So let's say, let me make something up here. Let's say you started off with, let's go 20 over 4, okay? And let's say you said, oh, 20 or 4 is a perfect square. I'm going to separate this and I'm going to make that a 2. Perfect. That is totally okay. But then you'll notice that square root of 20 needs to simplify. That's a radical that breaks down to a 4 and a 5, right? Well, square root of 4 is 2. And 2 divided by 2 is 1. So I'm left with square root of 5. Are there other options? Yes. Maybe some of you noticed, you're like, well, wait, Mortvet, 20 divides by 4. You get a nice clean 5 right away. True. Both are different pathways that lead to the same answer. So that's why I say these 4 bullets can be rearranged, can be used in a different order. You could simplify the radical, then divide, then simplify again. Depends on the numbers given. So this makes it tougher. There's not do this, then this, then this. There's not this set order and organization to every problem. You have to understand fractions, division, and simplifying radicals. Let's take a look at our examples. So first example here, I'm first going to rewrite this as 8 over 2. That is to my benefit because I'm predicting and I can see that 8 does divide by 2. Now, I didn't do anything with the radical. Dividing and taking the square root are 2 different operations. So now I say, what's the square root of 4? 2. Okay, do one thing at a time. Fraction first, then I did radical. This next one, it's under 1 square root, but take a look at that 4 and 36. What do you notice? Those are perfect squares. So I'm actually going to rewrite it as separate square roots first. What's the square root of 4? 2. What's the square root of 36? 6. And we never leave a fraction as 2/6. We got to reduce it to 1/3. So yes, it is an expectation that you can reduce fractions on your own. Let's take a look at this next one. I'm going to put a 1 here. And I'm actually going to, so I'm going to leave the 1/5, and I'm going to write one big radical for 15/20ths. Because that fraction reduces. Now, again, I'm not dealing with the radical. I'm only dealing with the fraction. 15/20ths, I can cut them both by 5, so I get 3/4. Oh, I'm going to write it as separate radicals, because what's the square root of 4? 2. So I have a 1 on top, a 5 on bottom. I now have a nice clean 2 on top, and this square root of 3, that just stays bad, right? It stays in, what do I say, radical jail? All right, when numbers are next to each other, that implies multiplication. So in my denominator, I have a nice clean 10. There are other pathways to get to that same answer. If you would rather reduce the radical 20 first and then go from there, perfect. You have options. Let's take a look at example 4. First thing I'm going to do, I know that 32 divides by 2, so I'm going to make that one big radical. Because then I can actually divide it. Not reducing a fraction, dividing. What is 32 divided by 2? 16. Now all I did was divide. The radical still exists. Now some of you might do this. You can, but square root of 1's 1, so that's unnecessary. Square root of 16 is 4. And that looks weird. When numbers are next to each other, we multiply. That's a 12, which gets me to a nice clean 6. Example 5. This one, I'm actually going to separate the radical. So I'm going to keep the 5 and 2. I'm going to keep the radical 3, but I separated it because what's the square root of 25? 5. That looks weird. What am I going to do to the 2 and 5? Times. So I have 5 square root of 3 over 10. These fractions, if I cover up that square root of 3, that fraction reduces to 1/2. So you got to reduce the radical and simplify any integers out front. Let's take a look at this next one. I'm going to write it under one big square root sign. Because 14 divides by 2, it divides nicely into a 7. I didn't take the square root. All I did was divide. Divide and square rooting are two different operations. These numbers, 4/8 simplifies down to 1/2. Done. I can't do anything about a 7, and I reduced my fraction. All right, example 7. Oh, look at that, square root of 16. That's 4. They're next to each other, so we multiply. 12 divided by 2. 6 again. Square root of 9. Square root of 9 is 3. We multiply those. 15/25. That reduces down to 3/5. This last one, square root of 18. First of all, can I divide those? It looks like those numbers go nice together, but nope. One's a radicand and one's an integer. We can't combine them if one's under and one's out, right? One's in radical jail, one's not. So let's deal with that 18. I can break that 18 down to square root of 9, square root of 2. See my previous videos about reducing radicals if you need. Square root of 9 is 3. That 12, I didn't do anything with it yet. I have a fraction out front. That reduces down to 1/4, and the square root of 2, still bad. So one of my biggest suggestions is you really need to separate the idea of when am I just dividing or reducing a fraction and when am I taking the square root. You're going to try to do things at the same time, and I encourage you to do one step at a time. Make sure you check out Google Classroom, and I encourage you as well, check out other YouTube videos. There are so many options. If you're struggling with your homework, YouTube. This is how you learn how to do everything else these days, right? You learn how to bake something, you learn how to fix something, you learn how to do TikTok dance, right? You watch a video. So on YouTube, type in dividing radicals, watch another video, listen to another teacher if you get stuck. Let me know if you have any questions, And until next time, have a good one.